Yet, pi appears in biological and physical contexts that seemingly have nothing to do with circles, suggesting it's embedded in reality at a deeper level than simple geometric measurement. Rivers meander in patterns that involve pi. The ratio of a river's actual winding length to its straight-line distance from source to mouth averages close to pi. This was discovered by analyzing hundreds of rivers and measuring their sinuosity, how much they wind compared to a straight line. But why does this process consistently produce an average ratio close to pi? The DNA double helix contains pi in its proportions. The helix makes one complete turn every 34 angstroms and measures 20 angstroms in width. When you calculate the helical path length compared to straight line distance and account for the geometry of the spiral, pi appears in the relationships. The fundamental molecule of life is built using the same constant we use to calculate circles. When measuring random variations in natural phenomena, like differences in leaf sizes on a tree or variations in animal populations, the statistical distributions often involve pi. The mathematical equation for a bell curve contains pi, and natural variations frequently follow these curves. But why should pi appear in statistical formulas describing random variation? Does this mean pi is fundamental to how probability and randomness work in the universe itself? Pi appears throughout quantum mechanics formulas. The fundamental equations that describe how particles behave at the quantum level contain pi in multiple places. The equations wouldn't correctly predict experimental results without pi appearing in these specific positions. Einstein's equations describing gravity and space-time curvature contain pi. The relationship between mass, energy, and the curvature of space involves this constant. Perhaps most mysteriously, pi appears in calculations involving fundamental constants of particle physics. The fine structure constant, a dimensionless number characterizing the strength of electromagnetic interaction, involves pi in the complex calculations that determine its precise value. Why should a property of subatomic particles involve a ratio of circle geometry? One mathematician who calculated pi to millions of digits noted that the appearance of pi in contexts unrelated to circles suggests it's more than just a geometric ratio. Pi seems to be woven into the fundamental mathematics underlying physical reality, appearing wherever certain types of mathematical relationships exist in nature.